So in this problem, we're given this function and we're asked to find the vector u, the gradient, and the directional derivative if we're starting at the point 141 and we're pointing towards 524. So I'm going to try to draw a little representation of what I think this might kind of look like. We have this point right here, which we'll call, P, and I'm going to try to draw a little tangent line to that point, and then here is the gradient. Now I'm also going to draw a little circle around this because we're going to take the dot product, and I know that if I have anything below that level, it's going to be a negative dot product. Anything that's straight across this way is going to be equal to 0. So if I was going towards here, then this thing would be equal to 0. But if I were going towards here, then the dot product would be more positive. And I know the direction u would be in this way because we're looking from here to there. So we want a direction there. This is going to be point P, point Q. This is 141. This is 524. So PQ is simply going to be 5 minus 1, 2 minus 4, and then 4 minus 1. So PQ is equal to 4, negative 2, and 3. And then we want to normalize this because we're just going 1 unit in that direction, not the whole space, just 1 unit. So let's normalize that. And I think if we do 4 squared plus 2 squared plus 3 squared, square root that, we'll get the square root of 29. So vector u is going to be 4 divided by square root of 29, and then negative 2 divided by square root of 29, and then 3 divided by square root of 29. So that's vector u. Now for the gradient, we're going to look at this again. And we know that the gradient isn't that hard to calculate. It's just going to be the vector, fx, fy, and fz. We kind of already mentioned this here. Keeping in mind, this is going to be like the maximum slope, and this is the direction. So it's always going to give us like the maximum slope and then the direction. So when we're here, what's interesting is notice that if I have like a little bulb like this, and I was trying to find like the fastest increase, you can see like it's in that direction. Boom, it's like kind of pointing that direction. So I guess that's kind of what the gradient is trying to say. And then so then we want the direction and stuff like that. So we're going to take the derivatives, the partial derivatives of that equation and just split it up like that. So it shouldn't be too bad. Partial with respect to x is going to be just 7z. So we have 7z. And then the partial with respect to y is going to be 0. And then the partial with respect to z is going to be 18z to the 5th plus 7x. And that's going to be what the gradient is. But now we're going to find the directional derivative. So in order to do that, we kind of want to take the dot product. And I drew this over here because I know that if I have like a force in this direction, and then I just move in this direction, there's going to be no work done because like the force is in this direction. So if I move this way, like it doesn't matter. I can go this way as much as I want. If I start moving in this direction, I start getting some quantities. So if I start moving in this direction towards u, then I'll get a directional derivative. If I move in this direction, I don't get anything. If I move in this direction, then, well, I believe we just get like the gradient or something. So that is, that's what the directional derivative is trying to say. And if we dot u with the gradient, we will get the directional derivative. So I believe that's going to be, oh yeah, we forgot one more step. We have to evaluate this gradient at that point because this gradient is sort of telling us that it's along like any point. You could take it here or there, whatever, and that's going to be the gradient along the entire curve. So we want the gradient evaluated at 141. Okay, so that's going to be equal to 7, and then 0, and then 18 plus 7. So 7025. And then we can multiply this out. So we get that DUF equals 103 over the square root of 29. And that's a scalar quantity. So now we have our answers to this question.